Hello students, in this lecture we are going to see about Bcd Adder. Bcd Adder is one which is going to add two Bcd values. Before going to this Bcd Adder, first we should know what is Bcd. Bcd is one which is nothing but binary coded decimal. In Bcd we have the value from 0 to 9. That is, Bcd will be having only 4 bit to it. In that it will be for 0 it will be having 4 zeros. In the same way, if it is 9 it will be having 1 0 0 1. This is how we will denote our Bcd. As we are going for 4-bit Bcd, the maximum value what we can have is only 9, that is 1 0 0 1. So as we have addend and augment, the maximum value of our Bcd addition will be up to 9 plus 9, and this plus 1 is for that carry what we have. In that binary adder device what we are going to use will be having a carry, that is initial carry, which if at all taking a maximum value it will be 1. Hence the maximum value which our Bcd adder can add is nothing but 9. 9 is the maximum value of addend and 9 is the maximum value of augment, plus 1 is the if the initial carry is going to be 1. So finally or the totally the value will be 19. So this is the maximum value which it can add. Now we should understand the difference between Bcd adder and binary adder. This takes two cases to it. That is, if the total of the addition is less than or equal to 9, that is case number 1. In our case number 1, if the total is less than or equal to 9, the Bcd value and binary value both are going to be same. There is no change in it, right? Up to 9 there is no change in it. When it is higher than 9, when it is greater than 9, obviously we have to add. So look at this. First I will teach you this one. That is, in this example I have added 1 and 1 plus 5 where the output is 6. That is, as it is Bcd, it is going to have 4-bit value. So I am going to denote my 1 as 0 0 0 1 and my 5 as 0 1 0 1. So when I am going to add this, 1 plus 1 is 10. So 0 1 1, then again this 1 0. So this is nothing but 0 1 1 6 is nothing but 6. This is same for Bcd as well as our binary. Let's go for the second case. This case, when the total is greater than 9, that is, when I am going to add 5 and 6, my total is going to be 11. So 0 1 0 1 is my 5 binary value of my 5, and 0 1 1 0 is the value of my 6. When I am going to add it, I will be getting 1 1 0 1 to it. This is according to your binary value. I am performing the same addition by using Bcd. The value of 5 is going to be 0 1 0 1 and 6 is going to be 0 1 1 0. My adder output will be 1 0 1 1. If it is greater than 9, I have to add it with 6. 0 1 1 0 is nothing but the binary value of 6. So by adding 6, I will be getting 0 0 0 1 and 1. So let's come to this case. I have rewritten it here. That is, in this case 0 1 0 0 1 is nothing but 1 in Bcd and this is again 1. So totally now this value is 11 in Bcd. So this is how we will write or we will denote Bcd. The main advantage of Bcd is that you can easily convert it from decimal to Bcd. Directly by looking at it, you can directly convert. So this is our Bcd addition what we are going to perform in this section. That is, to say it in a crisp way, if it is greater than 9, that is you have to add 0 1 1 0 should be added. If it is greater than 9, we have to add 0 1 1 0 to it. Then this 6, how did you got this value 6? This value 6 is nothing but 10 to 15. Say for example, if I am going for binary value, I will be having a maximum of 0 to 15. In my Bcd, I am having the value of 0 to 9. The difference is, in Bcd, you don't have from 10 to 15. If you add from 10 to 15, the length of 10 to 15 is going to be 6. That is why we are getting the value 6, which is being adjusted to convert it into BCD value. Now let's look at the truth table of our BCD adder. This truth table is very simple. This is our binary sum and this is our BCD sum what we are going to have. I have drawn a line here. This is my important line which is going to show you the difference. So this is binary sum and this is our BCD sum. Look at this. Both this table and this table are exactly same for 0 to 9. There is no change. Look at this. 0, 0, 0, 0, 1, 1. The same way 0, 0, 1, 1. So from 0 to 9, there is no difference between our BCD and our binary. When it is getting exceeded, so the binary value of 10 is 0, 1, 0, 1, 0, whereas the BCD value is 1, 4 followed by 4 zeros. Here is where we are having the difference between our BCD and our binary. So where is the difference? Look at this C what we have. Also please listen, I have drawn my decimal value from 0 to 19. The reason why I have not written the binary value above 19 is that my maximum value which my BCD adder can add is only up to 19. That is why I have restricted myself up to 19. Other than that, that is after 19, everything will be don't care. Right? So now look at this C value. This C value is 0 for 0 to 9. The same 0 value is 1 when it is becoming 10 to 19. So I am going to draw a K-map. I am going to find the Boolean function by using K-map. Boolean function of what? C. I am going to find the Boolean function of C by using K-map so that I can form an equation with which I can perform the operation of adding 0, 1, 1, 0. Right? So I am going to this section. From the truth table, if C is equal to 0, it is coming under case number 1. The same way, if C is equal to 1, it is coming under case number 2. So I have to add 0, 1, 1 to the output what I have. From this relation, I am going to draw a K-map. Look at this. Where and all my C value is becoming 1, my C value is becoming 1 from 10 to 19, my C value is 1. So what I am doing, I am just mapping from 10 onwards, 1, 1, 1, 1, 1 I have mapped. Then 16, 17, 18, 19. These are all the values where I have my C value. Then from 20 to 30, everything is becoming don't care. The reason why it is don't care is that I have the value only up to 19. And apart from that, all other values are going to be don't care. So now I have to map the K-map. So this is a 4 cell combination. Actually, this will be an 8 cell combination. This is 1 4 and this is 1 4. So actually this is 8 cell combination. The same way, this is also another 8 cell combination. So totally I am having 1, 2, 3 combinations here. So this value is going to be here, Z2 and Z1 are getting cancelled, and K0, K and K1 is also getting cancelled. As I am having don't care here, K is also getting cancelled. So I am left out with Z8, Z4. So one of my value is Z8, Z4. In the same way, look at this case, all the values are getting selected. So Z8, Z4, Z2, Z1, everything is becoming 1. The only thing which is left out is K. So I am writing K here. Then the last value is this, where in this Z4 is getting cancelled and here my Z1 is getting cancelled. So I am left out with Z8, Z2. This is how I am getting the Boolean function for my C. Now let's go for the diagram, where this is my augend and this is my addend. Totally I have 4-bit value in this. The same way I have 4-bit value in this. I am having a carry here. What I am using is just a 4-bit binary adder. So by doing this, I will be getting a binary output. So in this output, I have to check whether it is coming under case 1 or case 2. For this purpose, I have directly given all this output here. In this, if it is coming under case 1, I have to add 0, 0, 0, 0. I will be adding 4 zeros to it, which is not going to do any change in my output. In the same way, if it is coming under case 2, I will be adding 1 to it, which is from the equation C what I have got. Look at this. This equation C is nothing but Z8, Z4, then Z8, Z2, and finally K. All these things are added, and I have given this to this value. So this 2 value is permanently going to be 0, as my added value is 0, 1, 1, 0. This value, this 2 value will change. If it is coming under case 1, this 2 value will be 0. So all the 4 values will be 0. That is not going to do any change in my output. In the same way, if this value is coming under case 2, this value will be 1. By adding 1, 0, 1, 1 to it, I'll be converting this into BCD value. This is how you will perform BCD adder.